So over the past 2 days, we've had some amazing talks. Providing the last talk is not easy. And instead of zooming out and kind of trying to capture everything, that's one way to do it, and that I could. But instead, I'm going to zoom in, and we're going to go a little bit deeper on some of the things that we've been hearing about. So we're going to get into the deep and dirty of metrics. And some of the things that we heard in the other talks, particularly Tammy's, we're going to go and figure out how a lot of these metrics are defined and how to handle measurement in the wild. So first up, of course, load is a hard thing to pin down to one particular point in time. There's really no point in this whole continuum of this page loading where I would just say, yes, that's it. So we need a different vocabulary to talk about that. Page load can't be captured by just one metric. Like Tammy said, there's no one unicorn metric that you can have that summarizes absolutely everything, no one point in time. So yeah, these are some nice questions to ask. Really kind of user-focused. These are really all about load in particular. This last one, is it delightful? This is a lot about actually what we heard from Anna yesterday. She got into kind of 60 FPS and smooth animations and nice transitions. That's what delightful is about. You know, page has been loaded, but now from the experience from this point on, is it nice? Is it smooth? Is it good? So these are kind of the questions to ask. And it's all about the user at this point. So we got a nice little family of metrics that we've been hearing about in the last 2 days. We're going to group them into visual metrics, interactivity metrics, and walk through a little bit of how they're composed. All right, so starting off with the visual metrics, let's say we're loading a page, right? So I'm just going to make a search, and okay, I make a search, and then it's loading. Come on, and then yes. Okay, good, great. So I think, yeah, we're loaded. All right, so that, we had a nice sequence there. So let's expand that out to a little film strip. And there's different points in time here that we want to denote. First paint that there really was of non-white content. Okay, good. Contentful paint, there is content. Meaningful paint, sure. And visually complete, all done. All right, so let's go kind of in sequence here. We're going to start with first contentful paint. Funny little name. Really, this is just the first paint of any kind of content. Content is usually text, most of the cases, although if an image is the first thing to show up, or canvas or SVG, that would trigger it as well. Let me just move my mouse. Yeah, good, cool. Yeah, in fact, one glyph of text does satisfy content. All right, first, meaningful paint. How do you define meaningful? This is a little tricky one. Really, this is about marking the point in time where there's the most significant layout change and the paint immediately following that. Most significant layout is interesting. And so I want to explain a little bit about what happens there. So if we have a film strip that looks like this, one of the things that's happening inside the browser is, layout. We're finding all the DOM elements, and we're just choosing, figuring out the geometry, the position of them. And the internal representation of that is called layout objects. It mostly maps to DOM elements, although if something is display none, it's not a layout object. This is a view of kind of the cumulative amount of layout objects that have been added to the page model over time. And so you can see that, just a little bit, and then jumps up once, jumps up a little bit again. And so this point here is the most significant layout because we had the most amount of layout objects added to the page. It's a little bit trickier than that. It captures kind of page height, all these sorts of things, but that's the basic. The other nice thing about First Meaningful Paint is that it also tries to capture these sorts of problems, like what we heard from Zach yesterday. The flash of invisible text. Yeah, no text, no text, some text. Still missing some headlines over there. And First Meaningful Paint will actually wait. If there's any pending web fonts that are still loading, so the text is invisible, in the case of WebKit or Blink, First Meaningful Paint waits for those web fonts to finish loading. However, if there's any web font that only handles 200 characters or fewer, it doesn't care about those. And that's just because icon fonts. This is an interesting case because when metrics like this are developed, you really ideally want a metric that works well across basically every single website. And so you try it out, and then you find all these edge cases. Like, turns out icon fonts really kind of mess with some of these heuristics. So they can get complicated. One thing I just want to point out is that First Meaningful Paint is sensitive to small changes in layout and DOM. And sensitivity for a metric can be a good thing, and it can be kind of frustrating. In this case, what it means is, for instance, if we go back and we look at these two layouts, these two jumps, like this first one is just a little bit taller than the other, right? So this is the most significant. But it's possible that this one is it. This one is taller. Or it's possible that, one of these jumps was way over here. So First Meaningful Paint is a metric that can actually be, sometimes it's at 3 seconds and sometimes it's 7 seconds. And it really was a fairly minor change that made it jump to the other one. So that's something that you might see if you're measuring First Meaningful Paint, is kind of a bimodal distribution where it's jumping back and forth. All right. Visually complete, it's pretty straightforward to define. Pages visually done loading. We don't expect it to change kind of anymore. Two things that really mess with visually complete is modal pop-ups, like please subscribe to our newsletter. We're just going to ask you to do that with a screen that covers all the content. Or any image carousels that are just rotating. Hard to say when it's done if that's happening. So that just makes it a little bit hard for visually complete to add value. And that ends up having a bigger effect for this guy, speed index. So we've heard a little bit about it. We know it. It's a good friend, trusty metric. How is it defined? Let's say that we have these two possible loads. They both start the exact same. And let's say 10 seconds later, they both end the same. So they both take 10 seconds to get to visually complete. But clearly, the top one would be preferable to a user, right? Speed index is about measuring the difference between these two cases. And it does this by evaluating the percentage of visual completion at every single point in time. Percentage of visual completion is an interesting thing. Like if we have these two images, like how do you, 60%? How would you write that if you had to define it? There's a few ways to. And the way that is used in all the tools that I know of is with looking at the color palette. So basically, what happens is you take an image, you extract all the colors of it, sort it, do it with the other one, and then just compare the colors from the first image to the second image and see how similar they are, and then just quantify that. And that is how visual completion is handled in speed index. This has a few effects, but once we know visual completion, then we can plot it, right? So A, which gets more visually complete at the beginning, jumps up, and it's sitting at 90, 93, whereas in our second case, it's not so high, right? So we have this kind of look of how the visual completion works over time, and then we want to compute a number out of it. This looks daunting, but it's actually not. It's just an integral, and we're looking at the area above the curve. All right, check this out. So if we just take these curves, and then we just color in the area above them, and then we just take all that area and sum it up. That's it. That's speed index. So a small amount of area above the curve means a low number, and that's good. Whereas in this case, it's a high number, and that's bad. That's speed index. So it's an interesting thing because it actually ends up being a number that you could consider a point in time, like 1.2 seconds and 9 seconds. And in fact, when speed index was originally introduced, it was introduced as a kind of score, and it was just resisting being considered represented in milliseconds. But as of like a month ago, most tools that are all major tools reporting speed index all report them in seconds or milliseconds now. So yeah, there's just a consideration. Everyone was like, is it a score? Is it a number? Is it a time? Anyways, you can consider it a time because it mostly is. That specific point in time isn't necessarily meaningful. Nothing happened at that time. It just is, it's roughly in milliseconds. Okay, all right. A few considerations, though. Any changes inside of the viewport are a no-op. Let's say you have a absolutely positioned little banner, and during load, it just moves, down the page. Everything else is kind of staying in the same area. It just moves. To speed index, nothing really happened because again, we just extract all the colors, right? And color-wise, it's the same. Also, if like the page flipped upside down, it's the same as far as speed index is concerned. So that's kind of interesting, kind of good and bad. I do want to point out that to deal with this and also just to have a stronger idea of the movement of items on the page, there's a new metric on the horizon around layout stability. This is also being introduced as the layout jank API, which I don't love the name of, but like layout stability API seems like really wordy. Anyways, so this is on the horizon. There's actually an experiment. You can run Chrome with some flags to actually start getting this in your performance observer. But what it tries to do is measure the amount of movement of all of the DOM elements that are in the viewport over any course of time. So kind of cool stuff. So keep an eye out for that. Still experimental, not yet shipped, still going through standardization. A few more considerations with speed index. Any pages with non-white backgrounds actually get a slight benefit. So again, all of these metrics can be gamed if you really, really want to. Each individual metric can be gamed, but it'd be hard to game all of them at the same time. And that's a good thing. Modals and carousels, like I said, they really mess with visually complete, so they really mess with speed index. So if your site has either one of those, just know that speed index is not going to be terribly useful for you. All right, I have some life advice after I drink this water. Okay, if you find yourself to be an American and you're traveling internationally at a conference and giving a talk, and then you're like, I'll put some jokes in it because that's good. Don't use like American culture references as part of the joke because it doesn't really land. I learned this actually in Amsterdam like 7 years ago. I was giving a talk, and I don't know why. I really don't know what the context was. But at some point in the talk, I flipped to my next slide, which was this. And I was like, yeah, like, what's up, britches? The response was like that. Like, nobody really understood what, like, britches is just a weird name for pants that's English, it's sometimes used. I don't know, britches, who knows? The dinosaur is irrelevant, but, So anyways, the joke totally bombed when I tried it before. This time, clearly, I have to explain it. It's terrible. So, wouldn't recommend, trying to do that. That said, I'm gonna try and do that. Back before Arnold Schwarzenegger was the governor of California, he was in action movies in the 90s, right? And he was in a movie back then called Last Action Hero. It was fine. It's a fine movie. 1993. If you were in the U.S. and you were like me, then you probably went and saw it once. Anyways, just putting that out there so that we're all on the same page. Just keep it right here. Okay, I'm just moving on to something completely unrelated, all right? So hero rendering times, we heard a bit about, hero rendering times is a nice way of looking at important pixels on the page, right? Not every pixel on the page is equal, and some of them represent really valuable content. And hero rendering times is a way of pulling out certain things that are really important. And at its first introduction, it was like, okay, biggest headline on the page, biggest image on the page, cool. And then somewhere it was like, yeah, okay, well, if we combine all these into a composite metric, that would be cool too. And then I was like, I like this combined thing. Is that called hero rendering times, or is that a new thing? I was like, which is the name? And it was, I was a little confused on like if the name applied, and so I go to Steve Souders, and I was like, Steve, I think that this thing needs a name, and I think that's not a name. And the best way to make friends is just to name things that other people have created, and just, it wasn't really a good idea, to be honest. But I was like, Steve, what about Last Painted Hero? Now you can see where I'm going with this. Yeah, like a Last Painted Hero. Yes. Huh. So, and he was like, oh yeah, actually, I can get with that. So, yeah, so that's, Last Painted Hero, right. What we're really interested in here is the last paint of critical content, so the biggest text on the page in the viewport, same thing with the biggest image, whether it's foreground or background image, and then just like, what is the last paint of that set, right? That's it. It's really nice. I also want to point out that there's been some movement here, too. Over inside Chromium, there's research around a metric. Right now, it's called FCP++. Clearly, I haven't like gone in there and tried to name someone else's metric again, and I think that's great, actually. And basically, to be honest, it might be more coincidence than anything, but it actually looks very similar to Last Painted Hero and First Painted Hero, kind of. Yeah, so it's still an exploration. There's research being done to try and figure out across a very large sample of sites what kind of combination of things really works. But anyways, just want to point it out. Research, public bug if you want to star it. Two of you have, so very nice. Yeah. Whew, okay, we're done with the visual metrics. And we're going to move on to interactivity. Interactivity is really key because someone came to your site and it loaded, and now that you do want them to interact with it. So when it comes to interactivity, probably one of the most important things here is what's happening on the main thread. And so I want to talk about main thread tasks. This is one particular main thread. Some things happening on it, for sure. Lots of JavaScript. Over on the left, we have a bunch of short tasks. On the right, tasks are a bit longer. Another question is like, okay, well, what's the difference between short and long? Well, let's get into that a little bit. And we take this main thread, and let's just say that, well, it's like the page is loading, and the main thread is going to be like this for sure. But while it's loading, I want to click on the menu just to open it up. Like I want to make a reservation on a restaurant site, right? And so I'm like, hit the menu at this point, right here during load. Well, main thread's not actually doing too much, so responding to that input should be pretty instantaneous. So that's great. If instead I tapped at this point, well, main thread was actually just started doing some work. And so that work is going to have to finish, and then it can handle that input. So we're going to have to wait just a little bit. But, of course, if it happens over here, well, 440 milliseconds later, then we can handle that input. That's kind of rough, you know. Tap the button and wait half a second, and then it starts to begin rendering, which is kind of frustrating. So clearly, over here, 440 milliseconds, that's a long time. The other ones seem short, but what is the threshold between the two? A while ago, there was kind of conversation around the rail model for performance. And there's some really good things about the rail model. Some people at Google introduced it, may or may not have been involved. But, and I say that because I want to point out that there also were some issues with the rail model. In particular, how it defined the goals for load, I think were underdeveloped and a little too ambitious. So just, if you ever dealt with Rail and was like, what they're trying to say for load doesn't make any sense, just, you were right, and I'm sorry. That was probably my fault, yeah. Anyways, the nice thing is that all this documentation, and especially the load stuff, has been revamped and rewritten recently, so now it's actually very well defined, quite good. One of the things that you might have seen before is, right, these are kind of response times, these important numbers, a lot of science behind these things, but 100 milliseconds is an important one, right? That's the instantaneous. I tap something, and if it responds within 100 milliseconds, I'm like, well, it was instant, right? So that's that one particular goal that's very important to input. So 100 milliseconds seems good. Is that the threshold? Well, if you read, the Rail stuff, it's always talking about 50 milliseconds. 50 is not 100. What's the difference? A little bit lower than that is this diagram, which is something, and it's nice. It's added recently. But I'm going to try my take on this instead. So what we have is a main thread. Let's say that I tap it at this point in time. Main thread's really not doing much, so that's cool. So page is going to have an event handler to handle my input. It's going to do a style and layout and paint, and then we'll see the pixels, and that's awesome. So that's kind of successful. We call that input latency, the end-to-end measurement from the tap to seeing the results, seeing the paint. That is input latency. But let's say on the main thread, we have a big, long task hanging out, and I happen to tap during the middle of that. Well, in this case, we got to wait for that work to finish before the event handler can run, and then the rest. So this is kind of pushed out quite a bit. And we call that input delay. The amount of time that it took between when the tap was first registered to when JavaScript event handlers could actually start dealing with it. And this is the difference between 100 and 50. We think that event handling should take 50 milliseconds, and input delay and any other kind of browser overhead should also be under 50 milliseconds. If these two things are good and satisfied, then the input latency in total should be fine and successfully under 100. So that's just the difference between those two. The important thing to know is that long tasks are real trouble for handling input. And the more long tasks you have, the better the possibility is that a user is going to tap and have a frustrating experience. Now, it's possible to do all the same work just in smaller tasks, and really doesn't necessarily take a lot more time to do it. So it's certainly possible to do the same work, just split up. And there's been a lot of really nice things happening in the ecosystem where frameworks are rebuilding how they run things in their life cycle so that tasks can be run in smaller chunks. So with that understanding, I want to touch on a few of these interactivity metrics. First is time to interactive. So what we're talking about here is kind of one of the latest metrics possible. The load is totally finished because main thread and network are quiet. So really, that's what we're looking for. The definition of it is a little like this. Let's say that we have a network waterfall on the top. Our main thread, big orange blocks, are long tasks. So what we do is we start at DOM content loaded, and we look forward. And we're looking on the network waterfall to see when it quiets down. And quiet actually is when there's 2 or fewer network requests. And then we're like, okay, cool, it's quiet, great. From that point, we're like, all right, network's quiet. Now we look backwards, and we go back to the last long task. And we're like, all right, whenever that last long task ended, that is the time to interactive. So that's how it works. The thing to kind of point out here is that whenever that last long task is going to be it. So if you have like a third party on your page, which is likely, of course, if that third party happens to do something that takes not 49 but 50 milliseconds or more, that's a long task, and that's going to push out your TTI. And that can also be a little frustrating because if, say, you're working really hard on all your first-party JavaScript and trying to break it up and do less work, and you're successful with that, but your TTI is not moving, this is why, because you might still have that third party doing that thing somewhere around 10 seconds later, and it's taking a little bit of time. First CPU idle was introduced to kind of handle that case a little bit more. So a lot of times, these two metrics are right around the same point in time. But sometimes you'll see a little bit of a gap, and first CPU idle will be coming earlier. So the definition here is a little bit more complicated and annoying. We take all the long tasks, we just group them, we cluster them into big clusters and little clusters, and then we just look for the end of the last heavy cluster, and we want to see some amount of gap, usually 5 seconds, but technically, as time goes on in the load, we actually accept smaller and smaller gaps. So there's some fancy stuff going on here, but basically what it's trying to do is just find when the main thread starts to quiet down, but it's not so sensitive as to one long task just hanging out in the back. All right, so that's first CPU idle. Okay. First input delay is a different sort of metric because it is strictly a rum metric. Only makes sense in the wild because really it's looking at actual user input. So this is not something that really makes sense in a synthetic or lab environment. So let's say I'm loading the page, main thread has a task on it. Now if I tap early before it, we're good, right? If I tap here, not as good. But let's say right here, right? We have our event handler, the rendering lifecycle. This first part is my input delay, right? Now, a user's input could happen at any point in time. It really depends on what's on the screen. Some sites, it makes a lot more sense for users to be touching the screen early. Other sites, like a content site, they're just going to scroll, and probably not tap for a while. So it's very site specific as to when input delay or when the first input is going to happen. But the input delay itself is usually, the measurement is exacerbated by a lot of things happening in the main thread, kind of slowing it down. And so the only other thing I want to point out here is that not all input is something that first input delay cares about, only meaningful. And it's mostly just taps. Scrolling and panning and zooming are not included as part of this. It's pretty much just, yeah, like clicking, tapping things. Yeah, like last session, we were hearing a bit about conversations on percentiles. This is one in particular that you really want to just focus on the 95th percentile because you're collecting first input delay from all your users, and it's going to be happening all over the place. 95th percentile is going to make a lot more sense than pretty much everything else because you really want to focus on those cases when main thread was quite busy, they tapped right there, and 5% of the time on your site can be frustrating. All right. I think this is the last interactivity metric, and it's expected queuing time. And it's a way to describe how busy the main thread is. So let's say that our tasks look like this. We have a 2-second task, 4-second, and 4-second. And what we want to do is we want to summarize how busy the main thread is for this span of 10 seconds. And we want to just summarize this as a single number. So the way that we do this is first we look at what is the probability that someone could be touching the screen during each of these tasks. Well, pretty much 2 seconds out of 10 seconds, so it's basically 20% chance here, 40% chance here, 20% chance here. Okay, that's easy enough. Then we calculate, well, how long would the user be waiting if they tapped during these tasks? And to do that, we basically look at, well, if they tapped at the very beginning of this task, they'd have to wait. Yes! Thank you, thank you. 2 seconds, good. And at the end, they would have to wait. I love it, I love it. All right, and then we draw a nice little line, put that gradient in there, and it feels so good. All right, we repeat the same thing for task B. Task C is a little different. How long are they going to have to wait if they tap here? Yep, 4 whole seconds. And then here, it's going to be 2 seconds. And that's the last point that we care about, because this is the area that we're summarizing, right? And so this guy looks like this. Then we just take this, and we just like play with the geometry, and we just like flatten it out, and then we just say, OK. So the expected queuing time is 1.6 seconds, right here. And that is, for this particular main thread profile, if assuming that someone could have tapped at any point during this time, this is the expected queuing time that summarizes the entire time span. So this might be a really nice way of summarizing how much impact long tasks have on your users. Currently, this metric is not exposed in any tools, but it's something that we rely on kind of under the covers for a lot of the time. All right, that's it on the inside outs of metrics. Talk a little bit on measuring in the lab in the field. So these are 2 different environments. We have a controlled environment in the lab, and in the field, anything can happen. It's a lot different, and we only have so much insight and so many APIs there. So in the lab, it's nice because we can collect so much data. There's really a lot of things available to us. We can really start to dig in and see exactly what was happening. But it's not the real world, and it's just kind of scripted tests. The tools that you use here are things like Chrome DevTools, Web Page Test, and Lighthouse. I work on Lighthouse. I've been working on Lighthouse for 2.5 years now. This is the Lighthouse report for this conference venue, actually. So these metrics that I was just talking about, see all up there, summarized. Excuse me. And they have, we have a calculation that that completes this performance category score. And you can read about it if you're tracking this score. You can read about how exactly these metrics are weighted in order to determine this number. But what I like about what we're doing with Lighthouse is we really want to quantify how much benefit you can get from certain improvements so that you don't waste your time and really target the most impactful things. And the nice thing also is that it's open source, so if you're interested in what's happening, you can dig under the covers. If you want to contribute, we'd love to have that. In fact, Ward Peters, who's one of the contributors for the last 2 years, is here, and lives in Belgium, is here. It's awesome to have him here. All right. Then on the other side of things, we have field data. I think a lot of things have been said about field data, so I'm just going to go along. It's great, and there's a lot of stuff. So I want to talk a bit about what is available to be collected. One nice thing is long tasks. The ability to collect long tasks has been available, at least in Chrome, for like a bit over a year, I believe. Basically, yeah, you register a performance observer, and then down here, we observe long tasks. And then we're basically going to get back entries for every task that was longer than 50 milliseconds. And we're going to find out when it started and how long it was. And the attribution is really nice, too. It'll indicate kind of where it came from. If it came from an iframe or other work, you can see a little bit indication of kind of who may be at fault. If you want to measure input delay, event.timestamp is your friend. This property on an input event was actually only added, I think, like 3 years ago. It reflects the time, the earliest known time that we have for that particular input. And oftentimes, it is quite a bit before what is observable in JavaScript. So the difference between what time it is now inside the event handler and the original timestamp, that is your input delay. That is your queuing time. So that's that, yeah. So just to kind of capture a few of these metrics and how you collect them in the field. First paint, contentful paint, you can just ask for them on the performance observer. It's real nice. Last painted hero, there's not a good way to capture actual real paint times yet, but there is a hero text timing API that's currently in development. So hopefully that will help round out that story. There is a polyfill for estimating queuing time, and also a nice polyfill for first input delay that I recommend you check out. First input delay is also getting kind of a first-class treatment soon, shipping into the performance observer with its own entry type soon. That's cool. Another nice project that's on GitHub is called Perfumes.js, just a JavaScript implementation of a number of these metrics that you can check out. User timing is great. It's so good. I love it. I use it actually in Node a lot because it was actually added to Node natively in like Node v10. So now you can use the same kind of measurement instrumentation on both sides and use cool tools for it. As you might know, you can see user timing inside the Chrome DevTools. And I really like this because if you've ever had like framework code, for instance, and you just have function names like begin work and finish class component, it's not really telling you much about which component is actually doing things. And so a number of frameworks do this now. They use user timing to tell exactly what's happening. And you can select that track in the performance panel, and the entire bottom, the kind of bottom up and call tree, will be scoped to just that. And then you can explore all of these timings kind of in your own language, which is really, really nice. There's a small project, experimental project, that just takes a look at what we can collect from Performance Observer and generate a trace that we can visualize. And it's really nice. What I like about this is just start collecting more data from the wild and visualize it. There's a lot of really valuable stuff in there. And also visualizing it, you start to see if perhaps some of your instrumentation is not exactly what you expected it to be. But at the core, like this project is these lines. There's a lot of data currently available to collect. And actually, like quick summary, we've heard about a number of these, but there's quite a bit out there. A lot of data to get insight on what's happening inside the browser. Some of the things that we didn't hear about too much of is intersection observer, resubs observer, but it really completes a very full picture of what's happening, and encourage you to check those out. I think, yeah, okay, good. Nice kind of way to look at this is working on a project, try things out, don't optimize too early, of course. Test things in the lab, try and improve it. Once you ship it, then validate it and take a look at all your metrics in the wild. Make sure that it's looking good. There'll probably be some things that stand out to you. Look at different percentiles. And as we heard in the last session, different metrics may suit you better. So definitely look into them and target the thing that you care about and your team cares about. And enjoy that cycle. I think that's it. Thank you guys very much.
I like you having that one because you can face the audience. I think that's better.
All right.
That was fantastic. Thanks for doing the closing keynote. I know that can be stressful.
All good.
I just totally feel like we're in high school because we're geeks and we're pretending to be action heroes. I just think you're James Bond, I'm Arnie. Only in our minds does that actually happen. So lots of questions coming in. I think Michelle still gets the prize though. Yeah. But lots of questions coming in. I'm wondering how to prioritize these. Okay, so toward the end, you had a slide that you were talking about RUM, about how to get metrics in RUM, the metrics that you had been talking about. I noticed a couple of things there. So why did you say TTI wasn't relevant in RUM?
Oh, yeah, that's a great question. Okay, so TTI, good metric. It's kind of the penultimate metric, right? If it moves and gets faster, then a lot of things improved. What happened is we tried out a nice implementation of TTI in Chrome, started collecting data, and the data ended up being not terribly useful. It was quite noisy, and it wasn't really correlating well with what we expected or what we were seeing in a lab scenario. And a lot of that just basically had to do with the fact that people interact with the page, and when they interacted with the page, they kind of changed the load experience, and thus the actual point in time that TTI was pointing to was not really comparable to the next person who loaded the exact same page. And so pretty much people's interactivity with the page really just messed with that, with TTI and like first CPU idle. Yeah.
But couldn't that also throw off like first contentful paint and first meaningful paint, or less so?
Not so. Yeah, could throw off first meaningful paint, but we don't really have a good way of measuring that in the wild, and that is also one of the reasons why it's not standardized. First contentful paint, because it is the first time that content exists. If someone is touching the screen before that, then they're just doing it out of frustration, right? Yeah. Like they don't see anything. So, yeah.
But I did notice that too. Is it looked like, and maybe it was just the brevity of the slide, it looked like you had the same, polyfill or whatever you want to call it for first paint and first contentful paint. Was that intentional?
Yeah, those two. are just emitted as performance entries in the performance timeline or observer. And so those have been standardized. Chrome is shipping them. I think Firefox is already or will soon be.
But they're not the same.
First, Paint and Contentful?
Yeah.
No, not the same.
Yeah, okay.
Yeah, Paint is just any paint that's not white. Yeah. But usually, to be honest, like 95% of the time, it's the same point in time.
I think I just misread the slide.
Yeah.
What was it like fighting Jaws in the Moonraker movie? Oh, never mind. That's I think I heard someone else kind of asking about this. I don't want to be annoying. Long task API is so awesome. You know from my talk how much I really think we all need to worry about CPU time. We don't have attribution right now. Long task has been out for a while, and attribution is in the spec. Is it a high priority to get the attribution?
Yeah, it is a high priority. It's just a matter of it's usually a matter of privacy and timing attacks. There's ways that privacy can be leaked by when we express that a certain iframe is at fault here, and so you can use tricks to malicious script could use tricks to basically sniff out private data through knowing some attribution. So we just have to figure out some things. There are solutions to deal with this, and that's kind of what's holding it up.
Can you think of any other way for someone with RUM to get an idea of the JavaScript CPU impact of third parties? Or there's really no workaround for that until we get attribution?
Yeah. So there is a technique. It is fairly gross. We know that Facebook uses it. They've talked about this at BlinkOn before. Facebook did also kind of create a JavaScript profiler client side. It's kind of insane. But what you could do, hypothetically, is set up a heartbeat every 5 milliseconds or less. And when that heartbeat doesn't fire, that's because something's happened on the main thread. You can instrument all your entry points of your application code so that you know that if the heartbeat pauses, you'd know if your application code is running. And if it pauses and it's something else, then you know it's at least not you. You don't know necessarily who it is. Yeah. That's, again, it's gross. That's kind of the best that there is right now, I think.
I love that hack. This is probably documented somewhere. I don't think I'm putting you on the spot. Someone asked, which metrics are used by Google in the page ranking algorithm?
Yeah, do you
Should
guys see that in the slides? I just had a whole slide of the entire search algorithm.
Should we ask Matt?
Yeah, I probably should ask Matt. Yeah, he'd know.
No comment?
Yeah, no, I don't know. I'm on Chrome, not search, and literally no one on Chrome knows anything about how search ranking works.
What I'm hearing is come up and talk to me after my third beer. Is that what you said? I thought that's what I might have misheard.
You could give it a
shot. Someone else asked, how does speed index deal with video animation stuff?
Yeah, it messes with speed index quite a bit. Yeah.
I thought Pat had a thing in there that would know it was a video and would ignore it after the first paint. No? It messes with it?
I think I don't know. I looked at that code recently. I don't think there's a thing for video, but maybe it does. Yeah.
I've been wrong before.
It would change
twice.
it. It would mess with it quite a bit.
Yeah. Okay. Here's... I hate to take advantage of my position. Here's a request I have of the user timing spec. I love the user timing spec. Yeah. The user timing spec does not let me specify a name like FID and give the value like 127.
Yeah.
And you have a polyfill for FID. I use that polyfill. It's fantastic. But I get this number, and I have to stuff it somewhere else to get it back to my server. It would just be awesome. So there are other things that people are measuring on their site that where you can't always do a mark and a measure, but you can get the value. And it would just be nice to roll everything back in the user timing spec.
Yep. Also, if you want to create a measure, for instance, and your start time is some point in the past, and there's no thing that you can refer to that already exists, you just the timestamp. You can't just create one, so that's frustrating. So there was a discussion about this. Basically, the solution is to allow you to create new performance entries. So just like the performance entry constructor, create your own, set the start time and the duration. So this is the plan. I think standardization stage, I think there's been a lot of conversation about it. It's probably being added to the spec soon. Yoav might even know. There's probably a few people here that know.
This is why you're like the James Bond in my mind. You have an answer for everything.
Happening-ish? Happening-ish. Yeah, good. I
think I've got one or two more. So I really loved when you said not all pixels have the same value. That's part of the motivation for the hero rendering times. I love last painted hero. What about first painted hero? Like we have first contentful paint, start render, or first paint, but this concept of some pixels having more value to the user, being more meaningful, works for both at the end, but also I think at the beginning.
No, I think so too. Like the biggest, it depends on like the page, and on some page like that headline is really key, or like on any kind of image hosting site, that image showing up is really important, and the text right beneath it, so like last painted hero, in that case, if that text takes a little bit longer, like I don't really care a whole lot. So yeah, it depends on the site, but yeah, first painted hero is very valuable.
I'm so glad that was your answer, because we had another question about when the last painted hero t-shirt came out. But if we're going to have both, we could have you on the front, like fighting Jaws, and you could be the first painted hero, and I could be on the back, jumping through the, doing the last painted hero thing. Okay, last question. Setting up a performance observer, if you're a third-party monitoring service like SpeedCurve, is a pain to get going really early. Is there any chance down the road we might have like long task information available from the beginning, just like resource timing and navigation timing?
Yes, absolutely. And the details of which some people over here and here know, and I totally don't. There's this buffering thing, right? And so you can basically, what's happening basically is browsers were hesitant to start collecting a lot of this information until they knew that there was a consumer for them, and that so you registered an observer, you said, I'm okay with any potential overhead for these things, even though the overhead is pretty much for free. But the change is pretty much that browsers will just start collecting it for free, just automatically, and store it, and you can then say, okay, I want retroactively all the things that have happened. So there's a solution, performance observer, buffer, something. It's there. Right?
Okay, very last question.
You said yes.
Again, don't want to put you on the spot. Present company excluded, favorite speaker the last 2 days?
Oh, yeah.
Oh, that's okay. Tammy's shaking her head. Steve, I'm so disappointed in you. I know Chrome Dev Summit is coming up Monday. It was very tight for you to come out here. We really appreciate it. Fantastic seeing you.
It's been awesome.
Yeah. Thank you very much, everyone. Paul Irish.